So we're going to look at factoring trinomials where a is 1 and difference of perfect squares. So we're actually going to factor and solve. And I'll show you what the difference is in a minute. So first of all, if you are factoring a quadratic trinomial, let's break that down a little bit. A trinomial just means that there are 3 terms. Quadratic means that it's x squared or degree 2. And so we're just using these big fancy terms for it, even though it's really not that fancy. And so these will be of the form ax squared plus bx plus c in descending order, and a, b, and c are typically numbers. And so we're going to jump into our first example, and we're going to do the example, and then I'll write out some steps for those of you that like to learn that way. So the first example is x squared minus 8x plus 12, and we're going to factor it. And so with this trinomial, we are going to draw an x off to the side, and this just kind of helps us think things through. And so what we're going to do is essentially there is a number in front of this x squared, and it's a 1. It doesn't change the value or anything. And what we're going to do is we're going to multiply that a value of 1 times this c value of 12 and put it up here, and this is just organizing our thoughts. And that b value goes on the bottom, and we're going to keep the sign, so negative 8. And we are going to fill in the sides right here with numbers that multiply to give you 12, but add to give you negative 8. And so you can run through your factors for 12s. 1 and 12, 2 and 6, 3 and 4. Well, the only ones that work would be a 2 and 6, and then they would both have to be negative. And so there's tricks out there to help you remember, well, if this is positive and this is negative, what do my 2 other numbers have to be? So if you want to look those up, they do exist. Might have learned them in Math 1. And so then we're going to use what we know about factoring by grouping. So we're going to rewrite our trinomial, but we are going to rewrite it using 4 terms. So we're going to have x squared minus 2x minus 6x plus 12. So all I did was change this b term, this negative 8x, and I used the negative 2 and the negative 6. And then we're going to factor by grouping. So hopefully you're pretty comfortable with that by now. So we're going to put our first 2 together and our last 2 together, take out some GCFs. So between x squared and minus 2x, we're going to take out an x. That leaves me with an x minus 2. Between negative 6x and 12, we're going to take out a negative 6. That leaves me with an x minus 2. And remember, with grouping, we want these factors to be the same. And then my final answer is x minus 6 times x minus 2. And so we'll write out the steps for that. So the first step is to draw your x. And basically what we did a times c on the top and b on the bottom. And we found 2 numbers that multiply to give a times c, but add to b. And then step 2 is rewrite the middle term. And then step 3 is to just factor by grouping. And you can go back and look at the factor by grouping steps if you want them all in one place. So let's work another example. So we've got a squared plus 3a minus 40, and we're going to factor it. And so we will draw our x. We know that there's an understood 1 here. We multiply 1 times negative 40, put the 3 on the bottom. So we're looking for numbers that multiply to give me negative 40, but add to give me 3. So our choices would be 1 and 40, 2 and 20, 4 and 10, 5 and 8. And that is it, I believe. And so the only two that would work would be 8 and 5. And since my A times C is negative, one of these has to be negative. And so to keep this 3 positive, 5 would be negative. Then we'll rewrite it. So A squared plus 3A minus 40. No, I didn't rewrite it. A squared plus 8A minus 5A minus 40. We have 4 terms. We'll factor it by grouping. And then we'll take out a GCF. So we take out an A, that leaves me with A plus 8. Take out a negative 5, that leaves me with A plus 8. And it works out perfectly. So these would be if the directions say factor completely. Sometimes the directions are a little bit different and it says solve by factoring. And so that's really where you start talking about the graph, and we're not going to talk about the graph just yet, but we are going to talk about solving. So this example, we'll start with x squared minus 56 minus 10x. It's a little bit different. It's not in descending order, so we will rearrange it. And we're going to do it the same way, and so really it should be equals 0. That's the difference between solving and factoring, is that they have an equal 0 understood to be there. And so we'll still draw our x. And we are still thinking of numbers that multiply to give me negative 56 and add to give me negative 10. So think about those. This one's a little tricky. It ends up being a 4 and a negative 14. So that's not your typical 1 through 12 multiplication facts, but that's okay. And so we will rewrite. So I have x squared plus 4x minus 14x minus 56. Keep that equals 0. We're still going to factor by grouping, so far nothing has changed. Take out our GCF. I still have a common factor, so my last step will be x minus 14 and x plus 4. And so what happens now in order to solve it completely instead of just factoring? Here it's factored completely, but we want to solve. So what we're going to do is set both of our factors equal to 0. So x minus 14 equals 0 and x plus 4 equals 0. And what we're finding graphically is the x-intercept, and we'll talk about that later. So we'll just solve it. It's an easy one-step equation. X equals 14, subtract 4 from both sides. X is also negative 4. And so we have it solved. And so some people write their answers like this in these fancy little brackets. So we'll continue to practice with that. So again, factored would be stopping here. Solving is just an additional step. So another example, solve. So we'll have x squared minus 11x plus 30. We'll go ahead and draw our x. Multiply a times c. Remember, a is 1. We're finding two numbers that multiply to give you 30, but add to give you negative 11. So if you think you've got it, go ahead and pause the video and work it out and then check back for your answer. If not, we know that our two numbers are going to be negative 5 and negative 6. We'll go ahead and rewrite. And we'll factor by grouping. Put the first two together, put the last two together, take out our GCF. I'm going pretty quick through these because technically we've already talked about this. There is a video that talks about factoring by grouping. If you haven't looked at that, maybe watch that one first. And since it does say solve, I should have an equal 0 this whole time. And so remember, this is factored completely. To solve it, we set both of our factors equal to 0. And we're solving, and really what we're finding is the x-intercept, so where this quadratic equation crosses the x-axis. And so my answer would be 5 and 6. So, another example. We'll just factor this one, we won't solve it. Maybe we'll do one more of each. We've got 3x squared plus 24x plus 45. So what's interesting about this one is that my a value is a 3. Well, if you'll remember, when we factor, the first thing we want to do is take out a GCF. So we want to check to see if there's a GCF before we go further. So between 3, 24, and 45, there is a GCF of 3. And so that actually takes care of our A not being 1 problem. That GCF comes in handy a lot. So now we've got a regular quadratic trinomial where the A is now 1. So using that function on the inside, we can multiply 1 times 15, put it up top, and put B on the bottom, which is 8. So I need two numbers that multiply to give me 15, but add to give me 8. Well, that would be 3 and 5. And so we'll factor by grouping. So we'll rewrite it as x squared plus 3x plus 5x plus 15. I have 4 terms. Remember, that's the magic number of terms before factoring by grouping. And then we'll take out our GCFs. And then we'll take out our common factor. And then we'll put our outside terms together. But notice we are missing that very, very beginning GCF of 3. So we want to make sure to add it to the very end. And really, we should have kept it there the whole time. All right, we'll do one more and we will solve it. Let's see. 2x to the third plus 32x squared plus 128x. Pretty big numbers, and notice that we have an x to the third, so this polynomial has a degree of 3. And so we don't really know how to factor that, but we do know that if we take out a GCF, maybe that'll help us out. So we're looking if there's a GCF. Well, there's a GCF of 2 and x, so we're going to take out a 2x. That takes care of my leading term, so now my leading coefficient is 1, which is good. And it looks like all the other ones that we've been working on so far. So remember, at the very end, we need to make sure to keep this GCF, but in the meantime, we'll go ahead and factor this trinomial in here. So we've got a 64 on top and a 16 on bottom. I need two numbers that multiply to give me 64. Add to give me 16. 8 and 8. So I'm going to keep that GCF here. I actually remembered. And then we are going to rewrite. So x squared plus 8x plus 8x plus 64. I got to use parentheses instead of brackets. But now when I group it together, it's mathematically correct. And then I'll take out my GCFs in here. So I can take out an x. Take out an 8. And my factors still match. And so I have 2x times x plus 8 times x plus 8. That's correct. Since we are solving, we do want to go ahead and set all those factors equal to 0. And so this 2x, because it does have a variable, we are going to set it equal to 0. And since x plus 8 repeats, we only need to set it equal to 0 once. So here when we divide both sides by 2, x is 0. Here when we subtract 8 from both sides, x is negative 8. So my solution here is 0 and negative 8. So the last thing that we're going to look at is difference of perfect squares. And they come in this form, x squared minus y squared. So basically it means subtracting perfect squares. And basically you do this when you have two terms and subtraction. But your two terms have to be a perfect square. So that's all of your, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144, and we could keep going, but that's your basic ones. And you have even exponents. So in order to split it evenly, they have to be even. And so when we get through a couple of these, you'll be like, oh, these are super easy. And they are super easy, but you just have to remember that difference of perfect squares exists. Because you're going to look at it, and when you're in the middle of factoring all these other things, you're going to be like, what is going on here? So you got x squared minus 16 as our first example. And so you'll notice we've got two terms. X squared is one term, 16 is a second term. We've got subtraction, even exponent, and 16 is a perfect square. And so when we factor it, what it looks like, let me go back up here, we have the square root of our first term, the square root of our second term, one is addition, and one is subtraction. So when we take the square root of x squared, we get x, so we can start both sets of factors with x. One's going to be plus, one's going to be minus, and then we'll do the square root of 16, which is 4. Easy factoring. So the next example we've got is a 1 minus x squared. 1 is a perfect factor. X squared is an even exponent. We've got subtraction. It's two terms, difference of perfect squares. And so take the square root of 1 is 1. Start off both factors with that. 1 will be plus, 1 will be minus, and then we'll take the square root of x squared. So we'll have x and x. That's it. So just to show you, these are both factored, so now we'll solve same way we did before. So we've got 4x squared minus 25. And so we've got subtraction, we've got two terms, 4 is a perfect number, 25 is a perfect square, x squared, even exponent. So we'll take the square root of both terms. And since we're solving, it's equal to 0. So the square root of 4x squared is 2x. We'll start off both of them like that. One will be plus, one will be minus, and then the square root of 25 is 5. So that's factored. When we solve, we're going to set both of those factors equal to 0. And this is a two-step equation, but it's still pretty easy. So we'll subtract 5 from both sides. And then to get x by itself, we'll divide both sides by 2. So my first x value is negative 5 halves. And we'll just leave it as a fraction. So then over here, we'll add 5 to both sides, divide both sides by 2, and x is a positive 5 halves. So my solution are negative 5 halves, and just to save space, we'll do plus or minus. We'll do a couple more examples. I'm only going to ask you to solve ones that are quadratics. So we'll just look at a couple different ones. So we've got x to the 6th minus 36. Not a quadratic. So I wouldn't ask you to solve this one unless I wanted to get super crazy. But we have two terms. We have subtraction. We have a perfect square, 36 and a 1. Remember, there's a 1 here. And then we have an even exponent. So what happens is when we take the square root of x to the 6th, basically what happens is that we're just splitting that exponent in half. One will be plus, one will be minus. Square root of 36 is 6. Done. We'll just do a couple more. We'll just fill up the rest of the page and then we'll be done. So 121 minus 25y to the 4th. We've got subtraction. We've got two terms. Perfect squares, even exponent. Square root of 121 is 11. Start off with factors with 11. 1 is plus, 1 is minus. Square root of 25, y to the 4th would be 5y squared. So again, we just split that exponent into two equal pieces. You can think about it as multiplying. You can think about it dividing 4 by 2. Whatever helps you out. All right, I think we can do two more. So let's do 49x to the 8th minus y to the 10th. And so, got 7x to the 4th plus y to the 5th. 7x to the 4th minus y to the 5th. So I just split the exponents in half. 49 is a perfect square. A little bit trickier. And then let's do the hardest one here. So we'll have, nope. I'm going to go over here, just going to need a little bit more space. So let's try 4x to the 4th, y to the 3rd, minus 9y. So we have two terms. We have subtraction. We have perfect squares, 4 and 9, but do we have all even exponents? Well, no. 3 is odd, and this understood 1 over here is odd. But when we're factoring, we always want to make sure to do what first? Take out a GCF. So we're going to take out our GCF of y, and that should solve our problem. So we've got 4x to the 4th, y squared minus 9. That takes care of our odd exponents. And then from there, we just factor like normal. And that would be your final answer. So 2x squared y minus 3, 2x squared y plus 3. So again, I just took the square root of my first term and took the square root of my second term and then changed the two operations in between.